So we are dealing with the third problem in the collision series, and the third problem in the collision series is problem number 1.167. The problem is stating find the increment of the kinetic energy of the closed system comprising two spheres of masses m1 and m2 due to their perfectly inelastic collision if the initial velocities of the spheres were equal to v1 and v2. So let us begin by understanding the situation diagrammatically. So this is how we can express this situation diagrammatically. That is, the two particles m1 and m2 are moving with velocities v1 and v2 before collision, and after collision which the specified to be perfectly inelastic. So hence the two masses will stick against each other and will start moving with a common velocity. So the first thing that strikes us is that we can apply momentum conservation for the given situation. So we say initial momentum is equal to final momentum, and hence we can say that m1 v1 vector plus m2 v2 vector equals m1 plus m2 vc vector. So therefore the common velocity vector equals m1 v1 vector plus m2 v2 vector upon m1 plus m2. Now we need to calculate the magnitude of Vc. So for calculation of magnitude of Vc, we need to understand that it is the vector sum of v1 vector and v2 vector with the scalar multiplied form of m1 and m2. So if we consider this as two vectors, one of magnitude m1 v1 and the another of magnitude m2 v2, so the angle between v1 vector and v2 vector is not changing. So if I consider that initially m1 v1 vector is making an angle theta with v2 vector, so it is not going to change even if we multiply the scalar number m1 and m2 with the two vectors. So if theta is the angle between the two vectors, if we write here theta is the angle between v1 vector and v2 vector, so then if we write the magnitude of Vc, so we can take 1 by m1 plus m2 out from this loop, and then we say that it is the sum of these two numbers, that is m1 square v1 square plus m2 square v2 square plus twice of m1 m2 v1 v2 cos theta. So we'll be doing square root square. So rather than doing a square root square, we are keeping it this way. So this is the expression that we have of Vc, and this we refer as the first equation for this particular problem. Now we go ahead to write the initial kinetic energy of the system. So initial kinetic energy of the system. So we write the initial kinetic energy as half m1 v1 square plus half m2 v2 square. So we refer this as part A or A equation, and then we write the final kinetic energy of the system, and the final kinetic energy of the system can be written as half of the sum, that is m1 plus m2, and then Vc square. So Vc square means m1 plus m2 squared in denominator, followed by this part that we have. So we have it in square root. So if we write Vc square, so Vc square will turn out to be m1 square v1 square plus m2 square v2 square plus twice of m1 m2 v1 v2 cos theta. So this is the expression that we are left with. So we have kinetic energy initial, then we have kinetic energy final, and we refer this as B part of the expression. Now if we calculate the loss in kinetic energy of the system, so the question is asking us the increment in the kinetic energy. Rather than asking for loss, it is asking us increment in kinetic energy. So if we write increment in kinetic energy of the system, so we write it as kinetic energy final minus kinetic energy initial, and therefore we write it as delta Ke equals half of this term, that is we are left with m1 plus m2 times of m1 square v1 square plus m2 square v2 square plus twice of m1 m2 v1 v2 cos theta, and then we subtract it with initial kinetic energy. So if we multiply m1 m2 on both sides, so we write it as half m1 plus m2, so m1 times of m1 plus m2 v1 square minus m2 upon twice of m1 plus m2, then product it with m1 plus m2 v2 square. So this is how we get this expression, and on solving this we obtain delta kinetic energy as half of m1 m2 upon m1 plus m2, and we will be having the term minus v1 square minus v2 square minus plus twice of v1 v2 cos theta. So on solving this term we obtain something like this, and if we take negative common, then we can write it as minus half of m1 m2 upon m1 plus m2, and then on taking negative common we have v1 square plus v2 square minus twice of v1 v2 cos theta. So this can be written as the value of v1 minus v2 square. So we get the final answer as minus half of mu, or reduced mass, or we can just put it this way, m1 m2 upon m1 plus m2, and then magnitude of v1 minus v2 square. So this is the increment in kinetic energy. The negative sign is representing that there is a drop in kinetic energy. The final kinetic energy is lesser compared to the initial kinetic energy. So this is the final answer to this problem, problem number 1.167.